All right, so we're continuing our study of functions, continuing different ways to look at them. So the fifth way is going to be functions as tables and ordered pairs. This is how you're more familiar with functions just based off of your algebra study in college algebra and then any math classes leading up to that. And so a relation is going to be a set of ordered pairs. A set means that I'm going to have these curly brackets and then I'll have some things inside. The curly brackets just mean, hey, these all go together. And so the example says, which of the following sets of ordered pair represent a function? If the set is a function, write the domain and range. So we need a couple of definitions. Let's review from the last video. Function means that there is only one x value for each. There's no repeated x values. And then domain is going to be to list all the x values. And then the range is going to be list all the y values. And so there's a couple of review definitions that you'll need in this section, or in this specific section, this part. So number one says the point 2, 4, 2, -3, 4, 2, and 2, 6. So the first thing I'm looking for, is it a function? And remember, to be a function, you're looking at only the x values and making sure there are no repeated x values. So here are my x values, 2, 2, 4, 2. And so because 2 is repeated, it is not a function. And so because it's not a function, I don't even need to find domain and range. It says here, if the set is a function, then write the domain and range. Well, because this thing is not a function, there is no domain and range. All right, number 2, the set 1, 2, 3, 2, 4, 5, and -3, 2. And then I've also written it over here as a table, just so you can see the correspondence between ordered pairs and tables, how the point 1, 2 looks in an ordered pair versus in a table. The point 4, 5 looks in a table. So that way you see kind of how they line up side by side. So the first thing I'm looking for is this a function? So looking at the set of x's, 1, 3, 4, -3. It is a function because there is no repeated x values. 3 and -3 are different numbers. Now that it is a function, I want to find the domain and the range. The domain just means to literally list off all the x values. Now we do want to list them in least to greatest order. So I want to write this as -3, 1, 3, 4. And let's make that note. If you do not write it in that order, you won't get the, it'll tell you it's not simplified in my lab. And then the range is going to be the same thing, except I'm listing the y values. 2, 2, 5, 2. Same thing, I want to write them in least to greatest order. So you may want to write 2, 2, 2, 5. However, I don't need to write multiples. I would just write this as 2, 5. I do not need to write that in all those 2's out. And then let's look at, if I ask you to write this thing in an arrow diagram, what you would do is you'd put the domain on one side. So -3, 1, 3, 4, and then you would draw an arrow to the appropriate y. And so in my ordered pair, -3 goes to 2, and so I'm going to draw an arrow from -3 to 2. The next one, 1 goes to 2, so I draw my arrow 1 to 2. 3 goes to 2. And then the last one, 4 goes to 5. And so that's how that would look as an arrow diagram. So then you can kind of see some of these things side by side. And then our last way to view functions is going to be to view functions as graphs. And so this will be number 6, functions as graph. So I've got the relation that we just looked at, which just means set of ordered pairs. And what I want to do is create a table based off the ordered pairs, and then I want to translate those to a graph. And so for my table, I'm going to just write these with the first one in the x column and the second one in the f of x or y column. So I've got -2 and 3, 1, 5. I want to write these in order, 3, 4, and then 7, 9. Typically, we write the x's in least to greatest. And so I did do a little reordering there. Okay, so there's my table on the left. And then I want to write these plot these as a point on the right. Now, because this is just a relation, it's just a set of 4 points, you are not connecting these points with a line. So your graphs should just be points. We are not introducing lines until the next section in the book. So the first one, -2, 3. So I'm going to go left 2 because it's negative. So left 2 and then up 3 because it's positive. 1, 5. So I'm going to go right 1, up 1, 2, 3, 4, 5. The next one, 3, 4, I'm going to go right 3, 1, 2, 3, and up 1, 2, 3, 4. Oops. And then the last one, 7, 9, I'm going to go right 7, 1, 2, 3, 4, 5, 6, 7, and then up 9, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And again, we are not connecting those because these are not a continuous graph. They are just 4 points on a graph. All right, the next one, the point 1, 2, 3, 2, 4, 5, -3, 2. So I'm going to write it as a table. 1, 2. Oh, I want to write it in order. So let's start with -3, 2, 1, 2, 3, 2, and 4, 5. I'm going to plot those 3 points. So go left 3, up 2 for the first one, right 1, up 2 for the second one. The third one is going to be 3, 2, and then 4, 5. Again, I'm not connecting them. They are just 4 individual points. All right, and then continuing with that, I've got this vertical line test. Vertical line test is the same thing as a function, determining if it's a function or not, except I'm given a graph. So if you can have it pass the vertical line test, then it is a function. So this is just another way to tell, is something a function, yes or no? So I connect this with before. Before we said that to be a function, you can have no repeated x values. That was the original stipulation. Same thing, except now I'm just looking at a graph. And so no repeated x values, that is going to be my vertical line test. So what you're going to do is you're going to draw a vertical line on your paper, or you can just use your pencil, and you're going to slide it across the graph. And if at any point if at any place on the graph you can connect 2 or more points with a vertical line, it does not pass. So let's look at this one. So I'm sliding this vertical line across the graph, and my graph is not coming back over top of each other, and so it does pass the vertical line test. So yes, this is a function because it passed the vertical line test. Let's look at, well, let's just look at this one. So here's my vertical line. I'm dragging it across my graph. Well, when I am on top of my graph, it is connecting up every single point. And so this thing is not a function. Okay, here's my next one. Here's my vertical line. Oops. I'm dragging it across the graph. The graph is good. It's still good. There's no other graph on top of it, except when I get to here, there's a problem. Now I've got this point and this point on the same vertical line. So this one is not a function. As soon as it fails the vertical line test once, it's automatically all not a function. All right, let's look at this one. Here's my vertical line. I'm going to drag this thing across. It's good. I get to the graph, and it's still good. And so that thing is a function. All right, and then here's my last one. So I'm dragging this thing across. It's good, except as soon as I get into the graph, I've now got multiple vertical lines that it would not pass. And so no, it is not a function. And then the last thing we're going to look at is this composition, the last thing in this video. Composition is just a two-function machine. So you've got one answer going into one machine, it comes out, and then that becomes the input of the next machine. So here is my input. It goes into the first function. That output then becomes the input into function 2. And then you get a final output. And so what we're going to do is you've seen this fog and golf in your college algebra classes. We are looking at it from a very much easier way than maybe you are kind of thinking in your head. So this says, what if x equals 2? Well, if x equals 2, 2 is going into this first machine. So I've got 2 minus 1. That's going to give me out 1. Now, 1 is going into the next machine, which says 7 times 1. And so that's going to give me out a final answer of 7. Okay, let's look at the next one. Consider the two functions. Find the final output for each of the following. 5. All right, so 5 is going in to my first machine. So 5 goes in, 5 minus 1, 4 is going to come out. Well, now that output is going into my next machine that says, okay, well, now you're going to do 7 times 4, and then 7 times 4 is going to give me a final output of 28. And I do need you to show both of those things on the test. All right, the next one, 10. So 10 is going to go into the first machine. 10 minus 1 is going to give me 9. And then 9 is going to go into the second machine that says 7 times x, which is going to give me a final output of 63. And then the last one, A. And so A is going to go into the first machine, which says subtract 1. I've got A minus 1. Now A minus 1 is going in to the second machine as being multiplied by 7. And so I would want to simplify this and write it as 7A minus 7 would be my final output. And so just a note, you can write this as G of F, or you can write this as G of F, written either way. Like I said, we're not going to go into the full detail that you did in your college algebra course. We are just mentioning it as just that. It's 2 machines. The original input's going to go in, come out of the first machine. That's going to turn into the input of the second machine, and then your final output's going to come out.